Okay, so now let's get to the proofs. Okay, I'm gonna chat you guys through these because I know these can be a bear. Okay, so immediately when I'm looking at number 1, I'm trying to think about how can I turn this into what's on the right side, okay? So with this, I see that I have the same functions on this side, so I really don't want to deviate far from what I have. So I'm just gonna go ahead and turn this into cosine and sine. Remember that identity cotangent is cosine over sine. Same applies no matter what property there is. Okay, so when I see this, I know, okay, I can turn this into a common denominator. So I can multiply both the top and the bottom by sine squared theta to get those to be the same denominator. So when I multiply that through, I get cosine squared theta minus cosine squared theta sine squared theta, all over that same denominator, sine squared theta. So as I'm doing this, I notice, what do each of these terms have in common? Well, both of them have a cosine squared theta in common. Then what's left over if I divide each of these terms, which is what factoring is, right? Divide each of these terms by cosine squared theta. So I'm left with 1 here, and then I'm left with sine squared here. Okay, now at this point I'm pausing and I'm thinking, what do I need to end up with? I need to end up with a cotangent squared and a cosine squared, which means, what is 1 minus sine squared? 1 minus sine squared is just cosine squared, I ran out of room per usual, times cosine squared, and cosine squared over sine squared is just cotangent squared theta, and then we're left with cosine squared theta. So if you look back at the beginning, done and done. It worked. All right, let's go ahead and try another one. Okay, so I see that I have secant squared minus 1 over secant squared of theta is equal to sine squared. So it looks like I'm gonna have to eventually turn these things into sine and cosine. So what I'm doing first is I'm noticing this looks like one of my identities. Which identity has to do with secant squared minus 1? So I'm trying to think about it, and I remember it's that 1 plus tangent squared theta equals secant squared theta. And as I mentioned to a few of you guys in person, I'm going to mention again, I always write the identity at the top to remember how I need to rearrange this to get it to be what I want it to be. So this looks like secant squared minus 1, so minus 1. So then I know tangent squared equals secant squared minus 1. So I can replace secant squared minus 1 with tangent squared. Okay, so now if I separate these into just sine and cosine, I will have something that hopefully will reduce to this. So I end up with sine squared theta over cosine squared theta divided by 1 over cosine squared theta. Remember, we have these two fractions. We can go ahead and multiply by the reciprocal. Cosine squared over 1, and looky there. Those cancel out. And we are left with sine squared theta, which is what we wanted all the way from the beginning.